Assalamu alaikum. Welcome to grade 7 Sciences. Today I'll give you my first lesson on science topic from chapter number 1, Heating and Cooling. This lecture is delivered on these topics: Introduction, number 2, Heat and Temperature, and Kinetic Theory of Matter, including solid, liquid and gas. In the first, I'll start from the brief introduction of this chapter. So first is introduction. Now what exactly happens when we touch something hot and our senses immediately tell us to pull our hand away? Then you will consider it that something hot is around you. For example, if this marker is hot object and if I am touching it by using my finger, that is sense of touch, then it indicates that after touching I just drop it and pull my hand away from it. Why? Because my hand, that is the sense of touch, feels that there's something hot is around me. So what is hotness? After clearing this point that if something is hot, then you have to pull your hand away, is hotness. So what is hotness? Hotness is the amount of energy. Which energy? It is heat energy an object has. An object has. So this will become the definition of hotness, that it is the amount of heat energy an object has. This degree of hotness can be best understood by this example. So consider firework or spark from the firework all around you. What is firework? उर्दू में आपने सुना होगा आतिशबाजी. कंसिडर दिस कि एक फायरवर्क का स्पार्क यानी चिंगारियाँ निकल रही हैं, एंड ऑन द अदर साइड you have a hot cup of tea. So I'm making here hot cup of tea. This is the hot cup of tea. So exactly what happens between both? This hot cup of tea has much heat energy in it. Has heat energy in it. How much? A lot. While in a firework, that is spark of the firework, has less amount of heat energy, has less energy in it. So what is the basic difference between both? If you will feel by touching or by feeling the firework or spark of the firework, then you will not get burned, will not get hurt so much. Why? Because it contains less energy, less heat energy. But on the other hand, when you will drink a sip of hot cup of tea, what is it in? What thing is in the cup? It is tea, hot tea. Then your tongue will burn. What does this indicate? Firework has less heat energy, while hot cup of tea has a lot of heat energy, which indicate that a hot cup of tea hurt you, burned you very much as compared to the spark from the firework. The next topic is heat and temperature. Heat and temperature. Now both of these phenomena are not synonymous. They are not the same thing. So what is heat and temperature? We will find the difference now. What is heat first? Heat is the amount of, I'm writing only from here that heat is the amount of energy some object has or something has. It is the amount of energy something has. ये एनर्जी की वो अमाउंट है, मिकदार है जो किसी चीज़ में होती है. It is actually represented in the form of some units. So which units normally are used for the representation of heat? These are called joules, represented as J, and or kilojoules. Kilojoules represented as kJ. So these are called the units of heat. Now in the similar manner, what is temperature? Is temperature and heat are the same thing? No, they are different from each other. Now what is temperature? It is the degree of hotness or coldness of something. So it is a measure. It is a measure of how hot or cold something is. टेम्परेचर क्या है? टेम्परेचर किसी भी चीज़ के बारे में ये बताता है कि वो चीज़ कितनी गर्म और कितनी ठंडी है. हीट क्या बता रही है कि उस चीज़ में जिसमें आपकी हीट मौजूद है उसकी एनर्जी की मिकदार कितनी है. So both are different things from each other. On the other hand, temperature and heat, as I told you, they are not equal, they are not similar to each other. So what is the unit or what are the units used for measuring temperature? So units of temperature. What are the units of temperature? It is measured normally in degrees Celsius. It is degree, that is, this knot indicates degree. And what is C for? C for centigrade. Centigrade. So basically the scale on which we can measure the temperature is called Celsius or degree Celsius scale. Degree Celsius scale. One more thing about temperature is that it can be measured by an instrument called thermometer. What is it? It is thermometer or thermometer. So this instrument is normally used to measure temperature. Now we are going to discuss next topic, effect of temperature on different substances. What are these different substances? Liquid, solid, and gases. Now as we already know about that matter, that is any substance, exists in three different states, that is solid, liquid, and gas. And these substances or matters are in turn made up of small or tiny particles, and these particles are called atoms or molecules. Atoms or molecules. So we can talk about molecules or atoms, then these particles are moving about all the time. They are not still to their position. The more they got the energy from their surrounding, more movement they show. So the more energy the particles have, the more they move about. And opposite is also true. As they lose energy, they move about less. So this change in energy is what heat is. So what does all this thing indicate? That matters are basically existing in three different states, solid, liquid, and gas, and these are made up of small particles. These are made up of small particles. And what are these particles? These are atoms or molecules. If you will provide heat energy to these substances, solid, liquid and gas, what happens to all of them? They show different behavior. How do they show? How do they show different behaviors? Because when solid get heat, any solid gets heat, what happens to the solid? It will not move about. It will not move faster. In case of liquid, it moves faster than the solid. But in case of gas, the highest movement will be shown by the gases. Why? Because the gases have empty places, empty spaces in them. They will move randomly from here to there. They will change their position quickly. This will be shown in the next figure. To understand the concept of the kinetic theory of matter, kinetic theory of substances. So here I am writing the kinetic theory of substances or matter, which are solid, liquid and gases. What exactly happened in it? होता क्या है इसमें? Now I am making the three first of all different blocks to indicate that these are solid, liquids, and third one is gas. Now as we know that the different sort of structures are found in solid, liquid and gas regarding their particles, and there is specific arrangement of particles has been shown in the solid. So solid has hard and compact structure. Their particles are fixed in their mean position. They are fixed at their position. How? Suppose these are the particles which are present inside the solid matter. So how they are present? They are present very closely to each other. They are not moving an inch from their place. Only the vibration they can show. No movement has been seen in the solid. So when solid get heat, what happened to the solid? It moves a little, not very much. It only vibrate to their mean position like this. This shows the vibration of the atoms of solids. Why? Why it only vibrates? Why it doesn't move here and there? Because the particles of the solids have compact or fixed in their position in their place, and they are actually forming a framework. They are attached to each other in a framework, and this framework doesn't allow these atoms to move from their places. If I talk about the liquid, then when heat is provided to the liquid, what happens to the molecules of the liquid? So liquids have more heat energy as compared to the solid. Therefore, how the particles move inside the liquid? First I'll show you the placement of these different molecules inside the liquid. So they are actually far apart as compared to the solid. They are not closely packed with each other. They are far apart as compared to solid. So what happens? They move more as compared to solids. They move about here and there freely, faster, and changes their position quickly. In case of solid and liquid, we have seen little and no movement or vibrational movement. But in case of gas, what happens? After getting heat, the gas molecules show the random motion. What is the meaning of random motion? Irregular motion. Suppose these are the gas molecules. These are gas molecules. So they will move after getting heat, they will move from here to there. Wherever they want to go, they will move. And due to the empty spaces which are seen here. These are the empty spaces. So due to these empty spaces, they are actually continuously moving from here to there, which is called the random motion. What is this movement called? Random. Random mean azadana, azad, freely. They move freely. Now, examples which you have to note from here, for example, starting from solid, we have a good example of water in form of the solid state, that is ice. In case of the liquid, we are drinking the liquid water. So water is a very good example of the liquid. And in the case of gas, the steam, that is the water vapors, again is a good example of gas. So all these states of matter or substances show that they are moving about, little or more, medium. And what is this kinetic theory of molecules about? Kinetic theory of different substances about? So this kinetic theory actually indicates what is the meaning of kinetic? Movement, moving something. So this theory is based on the movement of molecules or atoms from their places, a little or more. In the kinetic theory of molecules, you have studied about the concepts of solid, liquid and gas. Now I am going to tell you that in solid, when the solid cools down, what happens to the solid? So as a solid cools down, heat energy is removed from the particles and their particles will move more and more until they stop moving and slow down. And even a point reached, then all the molecules are stopped altogether. So what is this point called? What is this temperature called? So this temperature at which all the molecules stop moving from their places is basically called absolute temperature. क्या होता है absolute temperature? ये वो temperature है जिस पर तमाम किस्म के solids, स्पेशली सॉलिड की हम बात करें कि उनके अंदर मूवमेंट ख़त्म हो जाती है, वो अपनी जगह से मूव नहीं करते. So what is absolute temperature? Once again the definition, note it down. The temperature at which the particles stop moving, the particles of which, especially solids, particles stop moving, is called absolute temperature. So you have to note this definition from the board. Now, exactly at which temperature you have to measure this absolute temperature, absolute zero temperature it is also called. Okay, absolute temperature is also called absolute zero temperature. So why it is called zero? Because we are mentioning here absolute temperature scale at Kelvin scale. So normally absolute zero is the temperature at which material has no heat energy in it. So this is the basic reason why we are calling it zero, because it hasn't got any heat energy. And in scientific instruments and different sort of thermometers, we can find that 0 Kelvin is basically equals to the minus 273 degrees Celsius. So this is another scale of measuring temperature and it is called Kelvin. Clear? So what is Kelvin here? It is indicating zero temperature, and this zero temperature is actually called absolute zero temperature or absolute zero, and it is equal to minus 273 degrees Celsius. Therefore, we can say that what is the range, what is the value of the absolute zero temperature? It is minus 273 degrees Celsius. After knowing this fact that we can measure temperature by 3 different scales, in which the Celsius scale, Fahrenheit scale and the Kelvin scales are known to us. So what is Kelvin scale about? Here, the next point related to the heat and temperature is the Kelvin scale. What is Kelvin scale? Basically, it is convenient for the scientific work, for the scientist. It is easy for the scientist to measure the temperature starting at the absolute zero. And this temperature scale is given the name Kelvin scale. It basically starts at absolute zero and has degree which are the same size as degree you have mentioned on the Celsius scale. So what is Kelvin scale? Note down the definition. The scale which is used to measure temperature starting from which value, or at absolute zero. Absolute zero is called Kelvin scale. So this temperature scale starting from 0 Kelvin, and on the other hand it is starting from, on Celsius scale, from minus 273 degree Celsius. Kinetic theory must be clear to you, and now we are going to take help from this kinetic theory to understand the concept of the different behavior of different substances. So kinetic theory also explains the behavior of the substances. How? Starting from this first point or phenomena which is called melting. What is actually melting and how does it occur? So melting basically is the conversion of solid form into liquid form. So this thing must be clear to you, that what happens in the melting when solid changes into liquid. This phenomena of conversion of solid into liquid by providing or getting heat to the solid is called melting. Suppose, consider an ice cube. If you provide heat to the ice cube, what happened to it? What happens? It gets melt into the water. This is suppose water. So which form is this ice cube? It is a solid state of water, solid form of water. And after providing heat, it gets melt, and due to the melting, it is converted into its liquid state. So what is basically melting? It is a conversion of solid into liquid on heating. Another phenomena which is important for solid, liquid and gases is evaporation. Evaporation, or you can also call it evaporation. So what is evaporation? Evaporate means conversion of liquid into gaseous form. So what happens in it? Liquid converts into gas by heating. An example of this conversion can be best understood if you will take water in a beaker. So suppose it is a beaker containing water. Now we are providing heat to beaker. What happens? After some time you will be noticed that at the surface of this water, some of the molecules of water will be starting or will be rushing or will move faster, and they will leave the surface in this manner that these water vapor will not be visible, and they will start making these water vapors or steam, and they will start moving or leaving the beaker into the air. But they are not visible to us. We can't see them. What are these droplets? What are these water vapors? Basically, these vapors are the form of gas, and this form of gas of water is called steam. That is the gaseous water. So what happens during evaporation? That liquid changes into gas by heating. So this phenomena can be cleared by this figure. Next process of representing the kinetic theory or behavior of the substances through kinetic theory is called condensation. You can also write condensing or condensation. I'm writing here condensing. So it is actually the reversal process of evaporation. It is the opposite process of evaporation. What was happening in the previous one, evaporation? The liquid changes into the gas. Now this time gas changes back to the liquid again. But what is actually the difference between both? Only the reversal process is occurring in between? No. Actually, the gas is changed into the liquid when heat is not involved. Heat is not provided to the gas. Heat is removed. So, when heat is removed from the gases, they cool down. And after cooling down, their molecules move not faster, not quickly. As we know that the gas molecules are moving faster. They have much heat energy in them. But in this case, in case of condensing, the gas molecules are not moving faster. Why? Because we have removed the heat energy. Now, there is no more heat energy present in the gas molecules. So, their movement is little bit slow. Not too much slow, but little bit slow, and now they are changing their state and they are changing back to the liquid once again. So this is the simple phenomena of condensing. As we are moving ahead, we can also observe that with the passage of time, with these phenomena, that is melting, then afterwards evaporation and condensing, the movement of molecules gets slower and slower. What is the reason? Because when the heat energy is provided to them, their molecules move faster. But if the heat is removed, they are moving slowly. They are not continuously moving. And again, there is a reason that their molecules are compacting with each other. They are coming closer to each other. So they have no empty or little empty spaces among them. Therefore, we can say that due to the heat energy, the molecules are mostly affected. Now, the next phenomena which I am going to tell you here is related to the freezing. Freezing. Freezing means conversion of the liquid state into the solid state. Liquid changes into the solid one. Again, what is happening? If you are providing liquid or heat to the liquid, it doesn't indicate that liquid, after getting heat, it will be converted into the solid, because it is not the melting state. It is not melting. It is actually the conversion of the liquid form into the compact form, or which is present in the framework in hard and compact structure. For example, consider this glass of water. If you will keep it in refrigerator, in fridge, for cooling it down, what happens to the glass of water? What happens inside the water? The molecules of the water will come closer to each other, and due to the less and no more heat energy, what happens to the water? It will freeze. It will convert or will be converted into the ice. So this ice formation will occur, which indicates that after removing the heat energy from the liquid, it changes into the solid state. So this is the another example of this phenomena. Next phenomena that is related to the behavior of substances, which is actually supported by the kinetic theory of molecule, is called conservation of mass. Conservation of mass. In your book it is mentioned mass is conserved. You can also write mass is conserved. What actually the meaning of conserved? Conserved mean to protect something, to save something. To save something or to protect something. किसी चीज़ को बचाना, किसी चीज़ को ज़ाया होने से, वेस्ट होने से बचाना. So how does this possible? ये कैसे मुमकिन हो सकता है? हम कैसे किसी भी चीज़ के वज़न को बचा सकते हैं? So in these sort of changes of state which we have observed earlier, only the behavior of the particle changes. The particles, in this sense, that one state of matter changes into another. But in case of mass or conservation of mass, the actual particles remain the same all the time. The total mass of the substance therefore never changes. Consider the example of water. As we have seen that we have different types of substances, just like water, which is a universal solvent, and water is that universal solvent that occurs in all different state of matter, that is the solid, ice, liquid water, and gaseous form of water. So this is the speciality of this substance, that it exists in all three state of matter, and here we are also mentioning here as an example of conservation of mass. What exactly happening here? If I'll take once again the example of ice cube and I'll provide heat to it, what happens to it? It will be converted, that is its solid state will be converted into its liquid state. And we also know here that what is the composition of water? How water is composed of? Water is composed basically of two gases. One is called, I think you are familiar with, hydrogen gas plus oxygen gas. So do you think that after this conversion of solid water into the liquid water, this composition will also be changed? Answer is no. Water will remain water. Water will remain with these compositions. That water will never change its composition, that it is made up of hydrogen and oxygen, so it will be remain and it will never ever change its composition. It doesn't indicate that it is in solid state, it is composed of hydrogen and oxygen, but in liquid it becomes something else. No, it can't be happen. One more thing which is important here, that normally we have seen in the case of ice cube that why it is melting. Why it seems that it starts or convert from its solid state into the liquid state. So why ice cube is melting? What is the reason behind? Because heat energy from the surrounding air is making its particle move faster. Whose particle? Solid particles. So where the solid get heat, if for suppose I'll take a solid piece or solid ice cube in the plate, I just placed over the plate, what happens to that ice cube? If I'll not provide any heat to it, what happens? It will actually get heat energy from its surrounding, from its environment, its room temperature. And after getting this heat energy from the environment, it starts melting and becomes liquid water.